I want to take everybody through the bicycle problem a little bit and make sure we're coming up with conclusions that make sense, because you kind of missed the boat in the rest of this assignment if you don't. So when you're putting your table together here, the idea is, of course, the paint spot on the tire is right here. We're looking at the angle measure if the paint spot is the terminal, basically at the end of the terminal side of the angle in standard position. We're looking at the height of that paint spot above the x-axis. Okay, so for example, at a 0 degree angle, this is 0 degrees above the x-axis, or 0 units above the x-axis. Okay, for a 30 degree angle, you've got a radius of 12. Maybe my picture doesn't look really to scale, but the height above the axis is going to be 6. Okay, and then for a 45 degree angle, you've got a 45, 45, 90 triangle. This would be a side of 6 radical 2. This would be a height of 6 radical 2. So you're going to be 6 radical 2 units above the axis, okay? It ends up being the y coordinate of your point each time on your circle is essentially what's happening here, okay? And then we've got a length of 12, and this is a 60 degree angle here. So we've got a little 30, 60, 90 triangle. We've got a 12, we've got a 6, we've got a 6 radical 3 would be that height right there. And then finally, once the paint spot hits the top of the tire, you've got a 90 degree angle there. And of course that radius is just 12, so it's 12 units off, okay? As that wheel continues to spin, remember the wheel is spinning this way, we end up with this point here for 120. The height here is going to be the same as the height here on that other side, okay? So the 60 degree angle and the 120 are going to match up. And so you can see here, we got a 6 radical 3 here, we got a 6 radical 3 there. And then it's going to drop to the same level as the 45 degree angle, which is 6 radical 2. And the 150 is going to have the same height as the it's a 30 degree reference angle there. So if this is 12 and that's a little 30, 60, 90 triangle, that's going to be 6. And again, not drawing a scale in my circle here, but you get the idea, okay? Now, as this continues to spin, you get points that are dropping under the x-axis, and those distances below the x-axis need to read as negative. So for example, for a 210, okay, this is 6 units above the axis. It's symmetric. It's a little 30, 60, 90 triangle again there, because you're going from 180 down to 210. If the hypotenuse is 12, this length down here is going to be 6, but it's 6 below the axis. So look at 210 here, we're at negative 6 height above the axis, okay? And then negative 6 radical 2, matching up with that point there. 6 radical 2 above, this point down here is 6 radical 2 below, okay? And we're going to get negative values all the way around. All right, so what happens if you graph this on a coordinate plane? So the coordinate plane here, we're going to have the y-axis representing the height, which I think hopefully makes sense. The highest the height will ever get is 12, and it can go as low as negative 12. And then we're just following the angle measure. So you're inputting an angle, you're outputting a height, okay? So we plot the point 0, 0. We start out at the origin. And we plot the point 36, and we've got a point that plots about right here. And 45, 6 radical 2 would maybe be, I don't know, something like that. And 60, 6 radical 3 might be something kind of like this. And 90, 12 would be up here at this point. Again, you have an actual scale that's drawn a little bit more carefully. So we drop back down. At 120, we have the same value that we had here. At 135, we have the same value we had here. At 150, we have 6. And then at 180, we're back to 0, okay? So on your graph, you should get this curve that looks kind of like this. Now on mine, it looks kind of like a half circle. It's really not a half circle. It's got a little more arc to it than that. We'll look at the exact shape. We'll look at some actual graphs on technology moving forward. But anyway, now it drops below the axis. So for 210, it's at negative 6, and so that's going to be like maybe there. And then negative 6 radical 2, and so on. It's going to get to negative 12 at 270. Okay, so it's going to do this kind of thing. And then if you continue your table, you're going to see that the wheel is basically going to come back around. So once we get past 270, our heights are going to be getting closer to the x-axis again, and you're going to get a graph that basically loops around and does this kind of thing. So you get one complete curve that does this sort of thing. All right? we're going to make a connection between this and trigonometric functions moving forward. Okay, remember we were graphing an angle measure and the height above the axis. Okay, the height above the axis is a y-coordinate. Remember when we graphed the sine function on the unit circle, the sine function on the unit circle is equal to the y-coordinate. Okay, this wasn't a unit circle, so we're going to have values that are a little bit different because our radius here was 12 instead of the radius being 1. But there is a very, very close connection between this problem, the graph that we created, and the graph of the sine function. Okay, now moving forward, I'm going to ask you to do something very similar in the next problem. I believe it's the one that's coming up, and that is to graph the sine function. And I'm going to ask you to make a similar table, but instead of using this tire with the radius of 12, you're going to be using the unit circle and finding each of those trig values. Or actually, you could put those in your calculator and just get the decimal equivalents as well. I'd really like you to use the unit circle so you can see the relationships here and the symmetry. Okay, so that's kind of where we're headed, linking this into the graph of the sine function. And the graph of the cosine function will be very, very similar, but just slightly different than the graph of the sine function. So anyway, that's where we're headed. Kind of wanted to give you guys a lead into that. We're also going to take a look at a little bit of software on the computer as well. So we'll do that perhaps in one of the next videos. So hope that helps.